Hi everyone, this is Ramprasad Pujari. Welcome to Python Programming Series Part 18. In this session, we explore the fundamental working of logistic regression and will focus on its function as a binary classifier. In the previous session, I did a brief introduction to logistic regression. We spoke about use cases and we also briefly compared logistic regression with linear regression to understand why logistic regression has a regression term in it. In this session, we want to see logistic regression as a binary classifier. There are three things that we want to do today under a demo session. The first one, we will create a binary classification data set, a very small data set with 100 samples. And the second thing, we will build and train a linear regression model on this data set, this binary data set, just to prove that classification problems cannot be solved using linear regression model. And the third thing what we want to do is here we want to build and train a logistic regression model on the binary data set, and then we'll try to show that how logistic regression function can exactly fit on the binary data set. So these three things we want to complete under demo session. For this demonstration, I will use Google Colab. As you can see here, I am on the Google Colab interface. I need three important machine learning library for this exercise. I need numpy library because I'm representing x and y as numpy n-dimensional arrays. So I need numpy. Similarly, I make some plots x versus y or feature versus label plot. So I'll be using matplotlib machine learning library for this. And the last one and the third very important library that I require is scikit-learn because I will develop my machine learning models like linear regression, logistic regression using scikit-learn linear model module. So these three machine learning libraries I require for this exercise. So I have imported them. Now, as I told you earlier, the three things that we want to do today. The first one, we need to create a binary classification data set. Instead of using a real world data set, I will go for a toy data set with 100 samples. And this is binary classification data set, meaning the samples out of 100 samples, 50 samples will have y equal to 0 and remaining 50 will have y equal to 1. So when I create a data set, I'll make sure that there are equal number of samples with 0 and 1. Now, in order to generate x and y, so what I do is for the x, I use a linspace function, and linspace function return evenly spaced numbers over a specified interval. So it actually returns 50 numbers starting from -5 till -0.1. So between -5 and -0.1, you get 50 numbers. And similarly, remaining 50 for the positive axis, positive side. So from 0.1 to 5, again 50 values. So if you concatenate it, x1 and x2, and make it equal to x, we get 100 numbers or 100 values. So this is how I generate x. Now, similarly, for the labels or for the y, as I told you earlier, it's a binary classification data set. So y can have only two values, 0 or 1. So now for getting zeros, I use a numpy dot zero function. And I mentioned the number of values that I want to generate, 50. So labels underscore 1 will have 50 values with 0. And similarly, labels underscore 2, 50 values with 1s. Then I concatenate it and I get 100 values for labels. First 50 are having 0 value and next 50 are having 1. So these will be my x and y. This is my labeled data set. So let me just plot this. I will plot X versus labels, and let me see the plot. So this is the scatter diagram. You can see that there are 50 points here at label equal to 0 or y equal to 0, and for the first 50 x values, and these are for the next 50 x values. The target variable or label will be 1. So this is my data set, and this is my feature versus target variable diagram. And I used matplotlib to create this plot. Step 2, now I have the data set. So what I will do is I will initialize my linear regression model, and this is linear regression initialization can be done using this particular function. And I will go with the default setting. I'm not mentioning any input variable, or there are some hyperparameter as shown here can be mentioned, and which we discussed in the last session also, but I will go with the default setting. As we know that the linear regression uses ordinary least square function as a cost function during the training process in order to compute xn optimal values for x and y. Now, there is a pre-processing stage which is required to reshape x value so that it will have the dimension 100:1. We know that x has 100 values. So, in order to bring the dimension to this 100:1, we reshape it. And after that, using a fit function, we can train the linear regression model by specifying x and y. X is the feature, labels, which is nothing but y or the target variable. So after the training, we get m, which is the coefficient of linear regression function, and c, which is nothing but intercept or bias. So we get m or c, and so this is how you can obtain, and we discussed this in detail in the previous session. So my linear regression function or the learning function is a straight line function, which is y equal to mx plus c. And then I will plot this learning function and along with the data points which I just showed you. So you can see that when I plot both the plots like data points, which already we saw it, and then this is the straight line equation obtained from the linear regression model. So if you observe here, what we can understand is this particular learning function doesn't capture the underlying data points. That means this particular function does not make any contact with the data points. So you can't use linear regression function to make prediction on any data. So this is what we want to conclude, that when you have a binary classification data, when you want to classify, when you want to perform classification, and when you want to solve a classification problem, then linear regression model cannot be used. So this is what we understand from this. Now, another thing is that these are my data points, and if I want to perform prediction, then I need a learning function which has this kind of shape. For example, if you look at this, so this require a S-shaped curve, and let us see how we can get it. So third and important step that we want to complete today is develop and train a logistic regression model. We want to prove that the logistic regression can solve this binary classification problem. So in order to build this logistic regression model, again, I will use the scikit-learn logistic regression function. I will initialize this. Let me call this as log_reg. Now, here, there are many things to be discussed. As you can see here, I am not specifying any input variable. There are a number of hyperparameters that we can set before the training can commence. But I'll go with the default setting. I'll take one more session, the next session, on these hyperparameters, how they can be set. A little bit a discussion we'll have on those hyperparameters. Also, the loss function which we use for logistic regression is different from the one which we use for linear regression. In linear regression, as we saw earlier, OLS function is used, ordinary least square, whereas here you cannot use that one because that is used when you want to perform a continuous perform prediction of continuous values. But here you need something that can will be useful for performing prediction on binary classes. So we have to go for a different loss function. So logic loss or binary cross entropy. So this type of loss functions are used here. So we'll discuss more about the loss function as well as the optimizers. So the optimization algorithm is very important to adjust the parameters like coefficient and intercept so that you get the optimal values. So we will initialize logistic regression, and more discussion about loss function as well as hyperparameter will be covered during the next session. Once you initialize it, then we can train the model on this particular data, labeled data, XN labels with 100 samples. After that, we will compute M and C, which are the parameters here. And so this will be the straight line equation that we get, mx plus C. But remember, so this straight line equation cannot capture the data, what we have. We have seen it earlier also. So then how do you the what we understood is the best function that can be used here is a sigmoid function which has S-shaped curve, something like this. So sigmoid, which is also called as logistic function. So that's why it's called logistic regression. So this is the function. Z is nothing but mx plus c, and m is the slope, c is the bias, which is a straight line function or a linear equation. And in order to convert this linear function into a sigmoid function, S-shaped curve, so we use this particular sigmoid equation, which is 1 plus 1 over 1 plus exponent of minus z, where z is our linear equation. Okay, so this y log will be the sigmoid function that we have, which is also called as a logistic function. So now we have we can plot all the three together. We can plot the sigmoid function that we can plot x versus y log, which corresponds to logistic regression, and x versus labels, which corresponds to, for example, which corresponds to x comma y, which corresponds to linear regression, and the data points. So all these three we can plot, and then we can analyze it. So if you look at this, these are the data points which we created, and this is the earlier function which we saw, linear regression function. Now the new thing here is a green S-shaped curve, which is nothing but the sigmoid curve. So that's how you got after logistic regression. So this clearly indicates that this captures the data point. It makes contact with this. So I can use this type of function for performing prediction on classification data, and especially when you have binary classification data set. So from this particular exercise, we understand that when you want to perform prediction on binary classification data set, or to put it in another way, if you have a binary classification problem, and in that case, you can solve it using logistic regression. So logistic regression is the simplest form of binary classification model. So in this, this is what we have seen. All the 3 points as we discussed, we have seen. We created a small data set to understand the difference between a linear regression and the logistic regression, and also to understand why linear regression model cannot be used for performing prediction on binary data, and also to show that how logistic regression can solve this particular problem, how it can exactly fit on the binary data. Now, next session, we will focus on the hyperparameters which you can set for logistic regression before the training can commence. And by setting this appropriately, properly, you can increase the performance, you can improve the performance of this particular model. So I will stop here, and more about the logistic regression, optimization algorithm, and the loss function will be discussed in the next session. Thank you so much.